Okay, so this is the 11th video in Critical Path Analysis NS3. And in this video, we are looking at network flow problems and specifically maximum flow. So the maximum flow is just the highest amount something could pass through each edge. So if we have a look at this example, I'm going to quickly draw. We're going to have 3 edges, and these edges are going to represent tunnels. So they're going this way, and this way, for example, and this way. And I'm just going to write, this one is going to have 9, 8, and 10. And so these are tunnels, and we're having water flow through these tunnels. And this tunnel here is allowing 9 litres of water to go through. This tunnel here is allowing 8, and this tunnel here is allowing 10 litres of water to flow through. So if we are asked to find the maximum flow for this network diagram here, let me just pop in the nodes. Then we have to see what is the maximum amount of water that could flow through this entire network. So here in this tunnel, we have 9 litres of water flowing through. 9 litres. But when we get to this node here, this tunnel only allows 8 litres to flow through, which means 1 litre will get stuck here and 8 litres will go through. When we get to this final edge, we have 8 litres flowing through. So only 8 litres can flow through this edge, even though it has a possibility for 10 litres. Which means the maximum flow for this network is 8 litres. Even though we have 9 litres at the start, the maximum flow that can get to the finish is only 8 because this middle tunnel only has a capacity of 8. So let's have a look at some more theory work, some more notes. So here is another example. So the one that is at the start is called the source, and the one at the end is called the sink. As you can see here, here is the source, then it will flow through the network, and then it will end up in the sink. So let's have a look at this diagram here on the right. We have 25 litres at the source, and it's flowing through our network diagram. When it gets here, 58 litres is allowed through this bigger cylinder. However, because we only have 25 litres from the source, only 25 litres could possibly flow through this cylinder towards the sink. So if you have a look here, we have 25 at the source, which means 25 will finish at the sink. So if something is full, for example here, it will have 25 litres and it will be full of 25 litres, whereas this one will have 58 and it'll only be full of 25. So we have 25 flowing through, and that means that cylinder here is saturated. It is completely full, whereas this one will have excess flow capacity because it has spare room in there. Let's have a look at another example. Yep. Here we go. So this example is the other way around. It's flipped over. So we have 58 flowing from the source, but by the time it gets here, only 25 is permitted to flow through the smaller cylinder. So at the source, we'll have 58 litres, and at the sink, we'll only have 25 because 25 can only fit in here. So this one will still have excess flow capacity, and this one will be saturated. Now here is an example. In this example, we have roads represented by the edges and cars driving on these roads. So question A, find the maximum traffic flow from A to E through town C. So if we're flowing from A to E through town C, we know we have to go up here, A, B, C, E, because we were asked to go through town C. So if we took this road along there, it would not go to town C. So we're trying to find the maximum flow through this town. At the start, we have 300. So we know 300 can go here. When it gets to B, 600 could go through there, but we only have 300 from A. So we know that the amount that could go through here is only 300. And then when we get to C, we have a potential 800 that could flow through, but we can't because we only have 300 coming along here. So the capacity of that line has to be 300. And so the maximum traffic flow from A to E can only be 300. Now let's have a look at the maximum traffic flow from A to E overall, including both the routes, including the pink route as well as the yellow route. So we know that 300 could go through the yellow route. So we're going to leave 300. Oh, I don't want that color. I want this color. 300 plus whatever the pink route is. The pink route, we have 500 going through, but by the time it gets to D, only 150 flow through. So then we're losing 350 and only 150 can go through. So this one will be full with 150 going through. It will be saturated just as this line AB will be saturated. So now we have 300 plus 150. And so the total that can go through from A to E overall would be 450. 450. Now, if you have a look at question C, question C says a new road is being built to allow traffic from town D to town C. So I'm going to go ahead and I'm going to put that road in straight away. So we have a road going through there from D to C. Put an arrow there. And this road can carry 500. So I'm going to mark 500 there. Oh, there we go. 500. Add this road to the directive graph. Well, we already have done that. So tick. And I find the maximum traffic flow from A to E overall after this road has been built. So I'm going to go and put my new route in green so we can see. Now we have 3 different routes, yellow, pink, and green, which means we're going to have to add together 3 different capacities. So we know the yellow route has a capacity of 300. And we know the pink route has a capacity of 150, which means we're just going to have a capacity of 1 more route, the green route. Now, if we have a look, we have 500 going across this line here. And we do have 500 going across that line there. But we already have 150 going across here. So when it gets here, we have broken up into 150 this way and whatever's left this way. So 150 minus 500, so 500 minus 150 leaves us with 350 going this way. So now when we're here, we have a capacity of 800, but we already have 300 going through it. So we just have to check that our new capacity coming through on the green line can fit. So 350 plus 300 is 650. So yes, we do have enough room of the 800 to flow through. So now we also have 350 flowing through. So that is our final amount. So we have 300 plus 350 plus 150. plus 350. And if you add those all up together, we have 300 plus 350 plus 150 equals 800. So our capacity now, once we've added that new road, is 800. So it's a lot greater than the capacity was before.